Hi, I just want to show you guys, instead of having people making up a bunch of quizzes or formatives, what we're going to do is I have a do-over formative. And because I'm going to be out and I don't want to have to open and close a bunch of stuff, and I also don't want y'all to have to come in and make up things, this is just how we're going to do it, okay? So first of all, I know some of y'all have, so I'm just looking, this is a screenshot I took from my grade book, okay? And these are our reflections. This was that bear video, okay? And it was out of 13 points. This was really weird, and I keep messing it up. I will never do that again. But in fact, it looks like I might have done it wrong in that class that I took the screenshot of. So I need to look at that. Anyway, here's our Unit 2 intro. So we have 4 formatives over this, okay? Some of us are missing some. Some of us didn't come to, we weren't here for this lab. And time is running out. I don't want anyone to run out of time for the end of the quarter. So I took all of the most commonly missed questions on all of these things, even from the lab one. So if you weren't here for the lab and you'd like to get credit for the lab, I can give you credit by taking this do-over. All right. So let's say that you are this person here and you have 100, 100, 71, and 100. Okay. The bear isn't going to change. All right. Except if it's if this is wrong, the percentage, I'll fix that. But let's say that you have 100, 100, a 93, and 100, or a 71 and 100. Okay. And you would like to do the do-over. Okay. Let's say you make a 70 on the do-over. I'm not going to change anything for you because that's going to put this lower. And the whole point of this is to show mastery and make it better. Let's say that you make a 100. Then what I will do is I will come in here and change that to a 100. All right. If you are this person right here and you, let me just, if you're this person here, okay, and you weren't here for the lab and you take this do-over and you make a 100, I'm going to change all of these to a 100. Okay. Let's say you make an 83. All right. I'm going to change these to an 83. I'm going to put an 83 in here because you showed mastery over this, even though you weren't here for the lab. But I'm not going to change this because you already have an 83 there. Okay. So this should help you guys. That's what the intended purpose is. And you only have to redo one formative. Okay. It has all of these teaks on it. Okay, so let's take a look at all of our most missed questions. Up here on this line, you can see the percentage of people that got this one correct. Okay, let's look at number 3. 79% of the people got it correct. I know in some of the classes we might have talked about this, but I just want everyone to watch this. So this one says, during which season is the North Pole tilted away? This is from that salmon colored sheet. From the simulations. Make this a little bigger for y'all. Okay, it's from the simulations, and a lot of us are still putting summer, right? Okay, the answer is winter. It is tilted away from the sun in winter. All right, that's why it's cold. Okay, let's see. That one was 78%. Let's do this one, number 8. 71% of people got this wrong. In which month is the northern hemisphere tilted furthest from the sun? Again, this is basically the same question, and it's December. Out of these choices, okay, it's the highest tilt is when it's on the December solstice. Okay, so that is the correct answer. A lot of us put June. I am not trying to trick you on these questions. I'm not asking you for the northern hemisphere and then trying to trick you about the bottom. I'm not doing any of that. So if I'm asking you about the southern hemisphere, I will specifically ask like what season or anything like that. But this one's not even tricky like that. Okay. Then let's see what else we got. Then we have number 10. What makes Uranus's seasons different from Earth's? This is from the Edpuzzle. A lot of us missed this because we didn't watch the Edpuzzle. What is this? This is 6th period here, looking at y'all. Okay, so as Uranus is like this, or I'm sorry, Earth is like this, right? We're tilted 23 degrees. Uranus is like this. So they're tilted way down like this. So the more you tilt, the more extreme your seasons are. Okay? So that is why the seasons are different on Uranus. Okay, number 11. In what season in the northern hemisphere is the Earth actually closest to the sun? Okay, what season? A lot of us miss this and put summer. It's not the distance from the sun. It is the tilt towards or away from the sun. Okay, in the winter, we're tilted away, but we are actually closer. The word we used for this was the perihelion. That is on the Quizlet, and you should have done that several times by now. So, or the booklet or whatever we have done, but peri means close. So perihelion is when we are closest to the sun, and that happens in July, which is in the winter. I'm sorry. The perihelion is in January, which is in the winter. I'm sorry, guys. It's late. I need to go home. Okay, but it's the winter. We saw, remember that picture that you wrote a haiku about? You can look back on that and you can see the perihelion and the aphelion. Okay. And the last question here is, in what season in the northern hemisphere is the Earth actually farthest away from the sun? Okay. So that is, when is our aphelion? That's the one we're the furthest away. And that happens in July. And so that is the summer. Okay. I swear there were more questions about Uranus on here. Maybe not. Okay, so that was the first formative that we took. It was about all of those simulations that you guys did. The blue paper, and then I changed it to the white paper, right? And then the salmon colored paper. So if you need to do any of those, it really will help you on the test to see these things. Okay. All right. The next one is the lab reflection. Okay. I know that a lot of us weren't here for the lab, but this formative actually asked a lot of questions specific to the lab. But if you listen to this video, I think you'll still be fine on the formative, like the do-over formative. Okay. So let's look at number 1. In this experiment, what we did with the model, what was our independent variable? Our independent variable was the different latitudes. A lot of times when you have a lab like this where there's an experiment, but you can't really change anything, we can't change the tilt of the Earth. We can't change the latitudes of the Earth, but we can pick different ones and measure our data from there. We talked about this in class. I heard some people say that we didn't talk about this when you were taking this formative, and you are wrong, because we did. When we talked about our graph, I said that you're going to put the independent variable on the x-axis, and you put the different latitudes on the x-axis. Okay? Okay. The next one here is number 2. In this experiment that we did with the model, what was our dependent variable? The dependent variable is whatever we're measuring. And when you guys were turning that, you were measuring the seconds of daylight. Okay? That's what you put on your graph. That's what you were recording. That was your data. All right? The seconds of daylight. So that's the dependent. Let's see. Number 5. Why is there such a difference between the daylight times in the poles and at the equator? Discuss 2 characteristics of the Earth that contribute to this. This one is weird, just because this was like an open-ended one that I had to grade. So I want you to go back and look on here, and you should be able to see my feedback that I gave you. I gave a lot of you guys, this was worth 4 points. I think I gave you 3.5 points if you got really close and you said it was because of the tilt. That's number one. And then this number two is because we're a sphere, right? A lot of you you got so close. You said that it was because of the latitudes, like the equator is it's just exposed more. But it's just because we're a sphere. I could tell a lot of you kind of knew that, but you just didn't say the word like the round shape or the sphere. So a lot of you missed points because you only gave me one characteristic of the Earth. And a lot of you correctly put that it was the tilt of the axis, but then you said something crazy like the other characteristic was the speed that we spin, or it's not. It's the roundness of the Earth. Okay. The speed is the same everywhere on the Earth, so that shouldn't make something different on the poles and on the equator. Okay. Next one is our angle of incidence paper. Okay, this is the one with the flashlight on the book, and we looked at those at that. Or no, it wasn't the data that I gave you. It was just the flashlight on the book, and we talked and we put the sun on the angle of incidence. You guys remember that? Okay, so let's see right here. A lot of us did very well on this. Okay, this says, according to this picture, what latitude has the highest angle of incidence? So I'm talking about this picture right here. If it says that and it has the picture, I'm not talking about like, overall all year long, what latitude has the angle of incidence. I'm talking about this picture right here. If you look at this picture, the angle of incidence right here is more direct than it is up here. Okay, and this is, you can't see it, it's the Tropic of Capricorn. Okay, so that is the correct answer there. Okay. Number 3, at what latitude would the UV index be the highest? This is basically the same thing, guys. Remember, the higher the angle of incidence, if I do this, I don't know. The higher the angle of incidence, the higher percentage of UV radiation from the sun gets through to the Earth. Okay, it gets filtered out by all the atmosphere and stuff. We also talked about how for you guys in the morning classes or in the afternoon, I told you about the morning classes. I told you that I like to look at my watch and see when the UV is the highest. And in the morning, it's always lower. And I'm looking at it right now, and it is 2 at 5 p.m. And that's because the sun is starting to go down, right? And in the morning, it's because it's up. It hasn't reached its angle of incidence for the day. Okay, it hasn't reached its height. So when it reaches its height, the higher it is, the more direct it is, then you have the higher UV index. Okay. Okay, I think that is good there. Let's look at, this is the most recent one that we did. This is the equinoxes and solstices. If you haven't done these yet, you need to do this before you take this, even take the do-over, even though you're listening to this. Okay, so let's take a look here. We have number 2. We have, which of the following is true about the sunrise on the June solstice? Okay, remember, it is going to be the most north that it is all year. The sun does always rise in the east, but trying to think of how I can show you guys this. But if this is our compass rose and this is east, and this is north and south. Okay, if we're looking at the sunrise on the equinox, it is going to be like dead east. We call it due east, all right? But as we get closer to the June solstice, it's going to be a little bit north and a little bit north until it reaches its peak. Then it's going to stand still. That's what solstice means. And then it's going to come down here. And then as we move towards the winter solstice, okay, it's going to get closer to the southeast. And then it's going to stand still. And then it's going to come back up here for the next solstice. Okay? I'm sorry, the next equinox. On the equinox, it is always due east. So for the sunrise on the June solstice, it's going to be as northeast as it's going to get. Okay? Okay. Oops. The next one is number 6. What's true about the amount of daylight and nighttime for the vernal and autumnal equinox? So I was speaking to a student and she was telling me that it wasn't clear to her that the vernal and the autumnal equinox, it's just the two different equinoxes, okay? So autumnal means the fall, which I bet you know, and vernal just means spring, okay? So it's just what is true about the amount of daylight and nighttime on the equinox, okay? And we said, what does equinox mean? It means equal night. So when we have an equinox, that means that the daylight and the nighttime, they're equal. We should have 12 hours of daylight and 12 hours of nighttime. And that's true even remember I talked to you guys about Oslo because my ancestors are Norwegian, right? We're Vikings. That's why I'm so cool. One of the reasons why I'm so cool. So even way up in the Arctic Circle, Oslo has 12 hours of sunlight and 12 hours of dark on both of the equinoxes in the fall and in the spring. Okay. And that's it, y'all. You did wonderful on these. Thank you for watching this. I am going to turn it into an Edpuzzle for you. Also, your sub today is Miss Maurer, and she used to work here in the testing center, and I love her so much. So please be very, very sweet to her. And if y'all need anything, I will be here on Monday morning and Tuesday morning. I'm also going to be here on if you have a study hall period, you can come in and see me. My conference periods are 4th and 8th, and you might just want to double check with me. Sometimes I have to leave early to take one of my kids to a doctor's appointment or something. I don't know if any of that is happening on Monday or Tuesday, but if you need to come in before your test, or if you can't come in before your test and you need to talk to me, I'm here. Okay. So, I just don't want y'all to forget that the quarter is over on Thursday and I am out on Wednesday. I'm going to go write our LTCs. Okay. Is this a sticker? Yay. I love you guys, and I hope you have a great day. I hope you are very safe this weekend. You turkeys, make good choices. I know it's ACL, but make good choices. Okay? Bye.